What's up, math fans? I'm back talking about geometry. You start by talking about the parts of it, like point, line, plane. Then you talk about the angles. One angle I want to talk about today is the straight angle. Let me draw it for you. Straight angle, first time I'm actually using a straight edge. Usually I'm freehand and cheat. Here's a straight angle. That was easy, right? I'll even pretend this was the vertex. We got a ray going this way. We got a ray going this way. And you should know that this angle is, well, I don't know, did you study? It's 180 degrees. That's important, keep that in mind. I'm going to use that later to make connections. I actually want to talk about triangles today because angles put together, you start to make triangles. Think about the word. Tri means three, and angle means angle. Look it up. An angle, again, is defined as two rays with a common vertex. There's my angle, okay? Then you got your different kinds of angles. I hope you studied. Acute, right, obtuse, straight, reflex, I'd break my elbow if I tried that, etc. No, etc. It's 5 of them. Let's say, make a triangle, 3 angles. If all 3 sides are the same of the triangle, it's equilateral. Again, you break up the word. Equi means equal. Lateral means sides, equal sides. All 3 sides are the same, it's equilateral. If all 3 sides are the same, it follows that all 3 angles must be the same. This angle, A, B, and C are also the same. They're equal to each other. So it's also equiangular. Means the same thing. If the lengths are the same, the angles are the same. And it works out that all the angles always measure the same no matter how big the triangle is. The angles themselves don't change, just the sides change. It's interesting how dilations work. We're not going to talk about dilations just yet. Another kind of triangle, only 2 of the sides are the same. Then we call them the legs. And this is the base. The base is generally on the bottom. I mean, if you flip the page, the base could be on top, but we still call it the base. And the legs are the congruent parts, okay? If you have 2 legs that are congruent, you got an isosceles triangle. If you have no legs congruent, this is different from this, is different from this, now it's scalene, which means the angles are also all different, okay? Again, these dashes, if you see single dashes, they're all the same, they're all single dashes. Doesn't mean it means 1, it just means they're all the same, equilateral. Only dashes here and here on the legs, this is congruent to this. I could even put 2 dashes to show this is different. And then I'm showing you 3 different dashes, meaning 3 different lengths. So, that's just vocabulary, and math isn't there yet. In a triangle, you have 3 angles. In fact, I took the time, the liberty of doing this. And while you're gonna watch my illusion here. So I have a triangle, and I don't know the measures of any of the angles, but I'm more concerned with if I could add up all 3 measures, what would I get to? If I knew it and I knew it and I knew it, I would add it up and it would be no problem. But watch this. Almost like magic. Here's angle 1. Hold. Here's angle 2. And here is angle 3. Now, should be interesting. I gotta make it perfect. Excuse me. If I line up this angle here, it's flush with that first ray, and then it kind of shoots off. Now, I'm gonna line up this angle so that these 2 are adjacent. And then, guess what's gonna happen here? It's gonna get messy. So hold on, let me make this one flush also. See what I'm doing here? I'm gonna rip it so it's perfectly flush. That is some good ripping skills, if you ask me. Now, oh, let me rip the other side too. Gotta hurry up before the Wi-Fi cuts out. All right, so I put this flush, I line this up flush, and this last angle is flush. Do you see the beauty of what just happened? This angle plus this angle plus this angle come together like Voltron to form what? All together they form that straight line, which means the sum of the measures of the angles in a triangle is always 180. A triangle is like a very special straight angle. Cool? Remember that when you start to make equations. Remember what I said, when you make equations in algebra or using algebra and geometry, thinking if it's complementary, supplementary, or equivalent, or vertical. Well, here's a new one. Is it going to add up to 180? I could use the word, what? Supplementary, to see if my angles add up to 180. So, let me give you a simple question and then a much more difficult question. You can give a young child this question. Here's a 70, 50, what's that guy? And the young child's going to sit there and he's going to go, or she's going to go, it's got to add up to 180. I just learned that. So what's missing? And then they can kind of start guessing and checking and I don't know. And hopefully they come up eventually with the right answer. A lot of them, they'll add these together. And what is that, 120? And then they say, well, it's got to be 180. So then they go to 180 and they subtract it. And this is fine. It's absolutely correct and it's great thinking. It's not quite algebraic thinking. Hopefully I get the right answer here. I don't know what that is. Go get a calculator. Let me know. Okay? Here's algebraic thinking. I'm going to make an equation. I'm going to leave that there so you could still get back to me. Algebraic thinking would say, I know 50. I know 70. I don't know this. I'm not going to use a question mark. I'm going to use it's x. Whenever you don't know it, it's x. But I know the sum. The sum is 180. Combine like terms, that's going to give me 120 plus x equals 180. Subtract 120, subtract 120. X is now alone, and 180 minus 120. Oh, you caught me. Thank you. You see, you are paying attention. I'm glad you're not just watching videos. This definitely should be 120 here. I think I made a mistake earlier. I'm not sure what I said there and I erased it so I can't prove it. Could you rewind that and make sure I said 120 earlier? So here's 120, sorry for that mistake. Okay, back to what I was saying. So when I subtract this, what do I get? No, I'm just kidding, 60, okay? X equals 60, the missing angle is 60, and everybody should be happy. Great job, that's kind of the basics and the algebra together. Now, let's get a little more challenging. By the way, if you're complaining about that algebra, you'd rather do it that easier way, you're doing the same thing. You're adding and subtracting. It's the same thing. Just because I put an X there, don't panic. Check out this question here. Take a second, look at it, think about what your plan would be. All right, time's up. Again, if I ever rush you, just pause it. Good. See, unpause and get back to work. In triangle ABCs, the first thing I'm going to do is draw it. Whenever you're doing something, and especially in geometry, step one should be to draw the diagram. I'll even make it bigger. How's that? A, B, C. Trust me, it doesn't matter where you put the A, B, and the C. Depends on how you draw it. But they're telling you the angle A is 2x. So however you draw it, that's where the 2x goes. My 2x is going here. Follow me? X plus 30 is going for B, and 3x minus 30 is going for C. Second step, try to build an equation. I'm always telling you, is it complementary, supplementary, is it congruent? What is it? You know it is supplementary. You know I'm talking about a triangle, and the total equals 180. What's the total? I don't know. Let's just add them all together. 2x plus x plus 30 plus 3x minus 30. It's got to add up to 180 degrees. It's a tough one. Did we do combining like terms here? Do you see like terms? I got a 2x, an x, and I might as well add that 3x while I'm at it. 2x plus x is 3x plus another 3x, 6x. 30, positive 30, negative 30. Lucky for you, it cancels out, so you don't have to put any whole number here or any constant here. You just drop down the equals 180. Divide by 6, and x equals 6 into 18 is 3, drop to 0, 30. Great job. And then they might just push you a little harder and challenge you and say, well, now that you know it's 30, What are all three angles? Oh no, I have to plug in, so much work. 2x, 2 times 30, 60, that was easy. X plus 30, 30 plus 30, 60, that was easy. And 3x, 30 times 30 is 90, minus 30 is also 60. That was easy. Now, last question of the day. Can you guess what I'm going to ask you? I told you all the kinds of triangles it is. You might have to identify what type of triangle this is. What kind is it? Is it scalene? Isosceles? You could argue it is, but you want to go with the best answer, and the best answer is equilateral. Alright, thanks for watching. See ya.